So the next thing came around was AB, and that is a mixture of both B designs, obviously, and A design. So like B, you have two output devices. It can be a BJT, a FET, whatever, bipolar transformer. There's a bunch of ways to do it. And they both are biased, but during the switching, there's a feedback circuit. So they can stay controlled during the switching and have a nice clean switch from the positive to negative rail. I think we have a drawing here of a simple AB amplifier output stage. As you'll notice, there's one, take your choice, FET, BJT, transistor, depending on what power you're making, pulled to a high rail, another one pulled to either ground or a negative rail, which we'll talk about later, a signal coming in, and your output. And by doing that, that makes you an AB amplifier. If you wanted to look at an A amp, you'd literally just take that bottom piece that says ML there and delete it. And then bias your top FET to 50%, and that would be your A amp.
Now, when you're saying biasing, you're talking about the transistor is on. There's current flowing through it.
Yeah, so you have to make a FET switch, you have to apply current to it, right, to make it switch. And the first thing you have to understand about BJTs and FETs and stuff, it's not just on-off, not like a relay, right?
Sure.
Relay, you hit voltage to it, it's either on or it's either off. In this case, it can be a little on, a lot on, all the way on. And so the amount of current going into it and the amount of biasing you apply to it defines that switching signal, basically.